Good evening, everyone. Pleasure to be here. I speak to everyone here, and I think you're also streaming live online. So that's a new one for me, even though this is the theme of the show. I'm Olly Walters. I've worked for TAG for the past 5 years. I'm the technical director for aircraft maintenance, and elaborate a little bit on the IT and cyber part shortly. Just to stress, anything that I do talk about in terms of my opinions are mine, not TAG's. So whilst I am here as a TAG technical director, you know, that anything that I say is my view, is mine. So okay. So when you leave here, or when you stay at home, I'm hoping that when you leave here, you'll look at aviation data a little bit differently. So I'm trying to manage two screens at the same time. There we go. So one of the things that is important, I think, when you're leaving, is that you will look at certainly aviation data, but maybe even your own data differently. And in a world which is now data centric, making sense of it may be someone else's job, but actually the responsibility for that information, that data, may actually be yours, or not the person who's doing it. So that's a pretty important part. And one of the challenges that I see quite regularly is this supply chain around how this stuff happens. So I'd like people to feel empowered to be able to challenge that, I think is the message. So to the point before, who is this guy? Who is Olly? So I grew up in the northeast of the UK, Durham to be more specific. I studied electronic engineering and went on to do an apprenticeship at a fuel and hydraulic tank manufacturing company, making fuel tanks for JCB, Caterpillar, Linde, that sort of thing. It was a fantastic experience, trying to understand the whole supply chain, the whole business end to end. The great thing about that was I got to play with lasers and 6-axis plasma cutters and stuff like that. So really interesting place. It became a really great platform for me to learn how to do things right, how to do things wrong, where to make mistakes. And even on one occasion, because I didn't get the data to the right place, I had to hand rework some hydraulic tanks myself because of a production cut-in change. But it gave me an appreciation anyway to the interconnectivity of how information needs to flow through that supply chain and how it goes through a business. That wasn't the sort of engineering I wanted to get into, however. It was aviation for me. So I started studying in about 2003, so 20 years ago. And fast forward a bit, brief stint in Teesside Airport and Cranwell, RAF Cranwell, doing some civilian military work. I started working here in Farnborough in about 2007, with about a 3 to 4 year stint in the Middle East, about 13 years ago, and working with your esteemed chairman, Mr. Dave Edwards, who I'm sure some of you will know. It was a great experience. Learned lots across that sort of widespread experience. I did broaden my experience over the travels that I have, fed my interests as an engineer. Not just aviation, I do enjoy learning about lots of different things. Find myself again when I came back to Farnborough, well, actually, even in the Middle East, doing some civil military work again, but also did some other things like setting up customs and immigration and stuff in the Middle East as well. So working closely with a bunch of software companies, especially over the past 7 years. I worked for TAG Aviation for the past 5 years as the technical director. That's for aircraft maintenance. And again, I'll talk about the IT and cyber stuff shortly. And for those of you who don't know TAG Aviation, TAG stands for Technique d'Avant-Garde, which and the company was established back in 1977. That's nearly 46 years ago, starting with the watch brand TAG Heuer. Initially synonymous with watches, but some of you may be familiar with what was previously the TAG Farnborough Airport, the Aviator, and those parts of the business now are no longer what TAG focused on. TAG are predominantly focused on business aircraft management, charter, and maintenance. So that's the area of field that I am in. I've had the fortune of working with lots of different people with huge amounts of experience, and I give great credit to that actually, because what people have learned over the course of 30, 40-year careers plus, I've been very fortunate in that information has been passed on to me in a very high stream data flow, if you want to use the theme of the talk. Working for TAG came with me with that challenge of the challenge in these concepts and this technique d'avant-garde. So I directed also the IT team for the past 2 to 3 years, and with the advent of the recent cyber security regulations, I also took that on board as well and brought through the company through the certification requirements for that. I thought I'd set the scene a little bit with something like the FDR, because we're talking data. FDR springs to mind for me. When you look at the accreditation of the invention of the FDR, you find yourself with a couple of people: David Warren, James Crash Ryan. This guy here. I think he used to test his own inventions. So there's a lot of people being credited with it, but this James Crash Ryan guy was the first guy who put the patent in the US anyway. If you keep venturing a little bit further back, you also get back to here in Farnborough in the 1940s, where you've got the Ministry of Aircraft Production also doing something very similar. So this is one of those, reinventing the same thing somebody's invented many, many years before. If you keep going further back, you end up with another couple of French guys who also invented it as well. And then if you keep going further back again, you get to 1913, where you've got George Diot here, who actually was doing flight data monitoring to determine how his aircraft was, flown by different pilots. So, you've got this understanding and appreciation of data throughout a period of time, for which there's a narrow field of people that have understood the value of that. And I think over time it's come to realize that, you've got very useful, beneficial things that can be done with this stuff. So what's the purpose of data in today's industry? We've gone from the likes of David Warren, who obviously was largely accredited with the commercial use of the FDR. He fought with the Americans for about 14 years in order to make use of that information. The Americans at the time mandated the FAA 88 data points, I think it was, for use on the FDR. To sort of conversations that I see on a regular basis when I'm trying to go about some of my, activities, which I find myself, dealing with data licensing agreements and lost my notes, excuse me. There we go. yeah, where I'm basically pushing manufacturers and suppliers to understand who's responsible for this, and you know how this information comes to change hands, and which is important, you know. So what was the turning point where people didn't really want this stuff to now everybody wanting it, and there being a lot of need to put in place controls and you know, possession of this stuff. Arguably, these days, this sort of information, it could be seen like you're putting a box in your car. I don't know if anyone's got a data box in their car to reduce their insurance premium, but you know, you've got a huge one in an aeroplane these days, and it captures a lot of information. And it's a far cry from probably, I don't know, 4 or 5 data points in 1913 that this guy was probably capturing. So the early thought process really was innovative, and now we've got to challenge that innovation when it's working the other way with suppliers having the information that maybe operators need, for instance. Okay. Look at this. That is a very short flight. Right down the bottom there, it's an Excel spreadsheet. You really can't read it. That there is 177,000 lines on an Excel spreadsheet of a sort of data file that I can see sometimes. And what's really interesting, if you look at this, is look at the time difference between all of those samples. There's not a lot of difference in that time. That's a sample every 0.625 seconds. That's 1.6 hertz. I've seen even more fidelity than that. I've seen 0.0625, which is 16 hertz, with 4 or 5 other data sampling rates in between that. So, and I'm pretty certain that that's not the limitation of the technology. It's a lot of information. This is one tab on a spreadsheet as well, so there are more. All we're looking at here is we're looking at a data record. Each one of these data records pertains to a sampling point. That sampling point in this data set, there are about 11,300 sampling points. So if we go to the mandated FA88, and then we go to maybe the 1913, you know, 4 or 5, there is a massive change in the sort of information, the volume, scale, the fidelity. It's huge. So why is it so important then? Well, about 7 or 8 years ago, whilst my son was still at nursery, I got to talking to one of the dads at the nursery who owns a telematics company. I can never say the word, sorry, telematics company. It specialises in the analysis of these little black boxes that are fitted to cars, and nowadays they're fitted as standard. Every production car for this manufacturer that he works with has fitted one of these boxes, and I asked him, would he have one fitted, and he said no. You know, you're working in a field of data, and you know, this is your business, and you wouldn't have one of these fitted. It's incredible. And when I asked him, he said, well, it's just too much information to give away, you know, regardless of the commerciality attached to it. Yes, it may decrease his insurance premium, but it wasn't worth that value and trade-off in terms of how much information he was giving away. You know, the conversation developed a little bit further because, in a geeky sort of way, which is, if you haven't picked up, that's probably what you can attribute me to. I was working with a few software companies at the time, and I was trying to determine whether or not I could establish, because there's a lot of EFBs on board aircraft these days. So, and those EFBs have typically got accelerometers in them, whether I could determine if you could establish the takeoff, landing, blocks on, blocks off time from something like an iPad. But you know, what else do you talk about in a pub? When you know, yeah. So in short, the commercial proposition of this information has got huge potential. And in the case of this guy, he was able to use it to establish safe driving practices for insurance companies. But you know, he said to people, look, you know, I could equally commoditize the data, anonymize it. I could sell it on to, you know, councils. Which are the roads that need maintenance have got the most bumps in them? Which are the roads that have got the most inefficient traffic, you know, calming and handling practices, you know? And then you can go, well, which shops are getting the most traffic bypassing it every time, and who can you target audience and target market be for shops and footfall and all the rest of it. So, and also obviously where people are speeding, because that'll be interesting for the police, I'm sure. So coupled with commercial use, this could be used to market to local businesses, you know. So this is why this information is important. So what does this look like in industrial scale? Not sure if you've got any Boeing experienced people in, but has anyone got an idea of the size of the Boeing Everett factory? Any? Yeah. Okay. 4.3 million square feet. 4.3 million. It's pretty big, isn't it? Yeah. So what about the Tesla Gigafactory? Anybody? Where Elon Musk is going to produce all of his batteries. 5.4 million square feet. I put a little scale on there. That's the Burj Khalifa. Beside that, that's the Tesla Gigafactory on end. What about Amazon data centers? 33 million square feet. Pretty incredible, isn't it? 3 million square meters. I think that's about 6 or 7 times the size. It's the biggest data center, by the way, is actually China Telecom, 10.8 million square feet. That's a single data center. So somebody somewhere thinks this is important. So I want a bit of audience participation here. So, and I've no idea whether this will work from an internet perspective, but please feel free to scan this QR code. I've constructed a little slide, which I'll put on the screen just after this, which I want to call Bingo, Data Revolution Bingo. And I've got a few words that actually some people may have heard before, but I'm interested when people hear data revolution, what sort of things pop into mind? What sort of things can you think about? So leave for a couple of minutes. And what I'm going to do, see if I can get this up on the screen. There we go. And you'll be able to see your words pop up. No abusive words, please. So Rolls-Royce used this one digital twin to basically monitor engines alongside the real life engine. data democratization. So this is about trying to give the right information to the right people where needed. So feel free to shove some words in. There we go. Information. I'm hoping someone's going to get a bingo at some point, and I'll put it up, and I will put the slide up shortly. Give it a couple minutes. So private, yeah, that's a good one. We'll come on to that. The bigger the word, by the way, the more people have said it. So I might have cheated a little bit and put a couple in before. Integrity, yeah. Okay, so let's see if there's any. Oh, another one's still coming in. Ownership. Right. You don't have to put your hand up and shout bingo, but I'll go back and put the words I associate with data revolution on the screen. And that's this stuff here. So AI machine learning. Probably heard a little bit about this, especially in the news recently, trying to understand the importance of, where responsibility lies with AI. Some people have lost their jobs and got rehired over this one. Data warehousing. You just saw the bit on data centers. The fact that we're putting aside so much space for data when compared to the factories that we use to manufacture aircraft, it's pretty significant. Talked about a few before. Data lakes, yes, this is a word. This is a term. Data mining. Digital transformation, predictive power. So a lot of this stuff stems from having information, what to do with it. So power queries, how to pull together that information, make sense of it, predict, analyze, make informed decisions rather than guessing. This stuff in today's world is important. So much like in the 1930, 1940, 1950s, there's somewhat of an inevitability of this sort of terminology. I think this will become a lot more familiar with people, certainly as time goes on. And it's been proven, I think, that it's going to happen, So there is some merit in trying to understand it. Even if you don't understand these terms today, I think there is some merit in trying to appreciate that there is, this is the world now, especially when it comes to what you've seen, volumes of data. This means that manufacturers and supply chains need this information. So what do they need it for? Well, people may be familiar with MSG3 when it comes to managing aircraft maintenance, reliability, component reliability, that sort of thing. Identifying trends in early failure analysis, designing improvements. How is actually the thing we design in the back end used at the front end? Well, if you get that feedback loop, well, then you can inform your design, you can make changes. Warranty claims, there's a commerciality element of it. So You know, can I reject a warranty claim on the basis of how somebody's used something? Well, if I've got all that data, I probably can. Did I put blanks on my engine when I parked it up for a period of time? Who knows? Engine trend monitoring, obviously, is probably a familiar one for most people. Accident investigation again. Training on FTM programs. You know, educating crews on how we actually fly the aircraft versus how it's intended to be flown. And then, of course, safety monitoring. You know, can we identify any trends before they happen and see if we can actually turn that into a preventable accident. All of this stuff gives rise now to data brokering and also putting it behind a firewall. That firewall I'm talking about is potentially from an intellectual property perspective. It could be because someone needs to pay for it. It could be a service. And this is kind of where we come to how the lawyers see all this stuff working as well. So if I look at how suppliers act responsibly today, inverted commas, I see data being traded as a commodity. So typically you'd have aircraft sold as is, where is. Well, now you've got data as is. Okay. People not making warranty, not warranting the information they give you. So imagine this for something like a maintenance manual, not warranting the data that somebody has given you to maintain an aircraft. Pretty significant. Wavering liability, all of these things that are pretty important when it comes to things like wavering rights of injury, death, and damage, loss. These are all terms that I genuinely see in data agreements or agreements whereby information is shared. And so trying to challenge this is very, very difficult. A lot of people don't look at the fine print. Next, we've got information. This one here deals with information sent to a supplier. One of the terms that I didn't touch on before, there was this thing called SaaS, software as a service. So no longer do we actually download and put a piece of software on the computer, but actually use software on the web. Some people might use Microsoft, for example, and now no longer you pay for it, you pay on a monthly subscription, and the product changes all the time. Well, software as a service is a thing. Actually, it's part of this other industry, which is called everything as a service. You buy TV as a service if you've got Netflix, if you've got, you know, and so imagine here in this one, all information and data collected from the services owned by, and I'm not going to disclose the person, but it's certainly not you. And what's really important actually is they can change it anytime without telling you. Sorry, I clipped off the notice. So not only have you given all the information away, but actually you rely on it, and you can't control the changes to it. So these sorts of things are where that responsibility changes. I got asked a little bit before about MH370. I think one of the things that's important is some of this stuff is only really known when something happens. So in the case of MH370, it was only worked out after the fact that there was data that actually could have been used and help track and identify where. Had we known about that before, we probably could have used that information in a lot more acute way, identified an earlier point of departure from track. So this data supply chain now puts the suppliers in a privileged position of holding the keys potentially to an operations understanding of what's actually gone on, but not just as they potentially did before, but in a lot more of a granular way, with a potential for a very, very short amount of data latency. So it's possible a supplier could know that something's happening as it's happening. And as an operator, for example, you'll only pick this up days, hours too late. And so if you've got terms like I just stressed before, then where's that responsibility crossover? Who's going to tell who that there's something that's useful, meaningful, and important? So I'll move on to this next slide here. I've touched a little bit on the FDR side of things, and this is not about FDR, by the way. And here I've got an image which, in preparation for this, I thought was quite relevant, actually. It's a pretty good sort of spread of how an operational, an operation gets lots of information from lots of places, and there's some little padlocks on here which indicate the security of some of this information. I'm sure many people recognise some of those terms, and largely on the left-hand side of this image, you've got information which pertains to, generally available information, weather, notices, geographical obstacles. And then as you move towards the right-hand side, you've got a lot more secure information, passenger information, safety reports, maintenance stuff. There's one point on here that kind of disturbs me a little bit. I don't know if anyone can pick it out. Can anyone notice it at all? Give the game away. ADSB. So ADSB is not secure. It's not encrypted. It's freely available information. So for those that are interested, you can actually get an ADSB receiver for $150. Here you go, $150. Ship it to your door. You can pick up all the aircraft transmissions. You can plug it in the internet and you can feed a community of data enthusiasts when it comes to tracking aircraft. Obviously, there's no one in the middle of the Atlantic, so I don't think you're going to pick something up over there. But those who are a little bit more into electronics, you can probably build your own, and they even give you the code to program it as well. Not only is information widely available to everyone with an internet connection, but for those people in private and business aviation, which is my world, we've now got another black box fitted, which we've decided to also broadcast unencrypted to the world as well. Is it just a privacy issue though, or a concern for those not wishing to let the world know where they're going? And will things change just because the rich and famous don't want to know where they're being tracked? Well, here, it clearly didn't work for this guy. We've got someone who set up that information, fed it to a service, to Twitter in this case, or X is now called, and I don't think he liked it, so tried to do something about it. And when he did, he just got Elon jet but delayed. So privacy's been respected for a period of time, but actually, realistically, the same information is just there. It's just being filtered out a little bit. One other area that I've got responsibility for is cybersecurity at TAG, and the Department for Transport gave the UKCA a mandate to understand the safety impact of cybersecurity on aviation systems, critical infrastructure services. There's also another regulation that came out fairly recently, which is EASA Part IS, which is putting a lot more emphasis on data management, especially this safety critical infrastructure. In respect to this area, just so I can gauge an understanding. Is anyone here familiar with CIA? You know the CIA? No, maybe not the CIA that I'm thinking about anyway. CIA that I'm thinking about is this one here, confidentiality. Some of the words actually came up a little bit. Confidentiality, integrity, and availability. So as we're looking at this particular model, you know, these three aspects here, when you deal with them together, significantly improve the security posture of any system organization to deal with threats, especially in the cyber world. Confidentiality, so we're talking about information that's not being made available or disclosed to unauthorized individuals or entities or processes. So that's probably in a simple way you can think of password protecting it. Integrity, talking about making sure the information is protected from alteration, because whilst you can put a password behind it, if it can be adapted and changed, will then significantly degrade the importance of that information. And then you've got availability, because if you secure the thing too much, then actually this word that I said before, democratization, you don't get that information to the right place, to the right person at the right time. So something like ADSB, well, if you were to secure it, would it have a significant impact on, you know, aircraft receiving transmissions? Would it delay it? Would it present a safety issue? So in the case of ADSB, the confidentiality part, in determining the risk of the data, should it be confidential? You know, there's a lot of argument to make sure that it is. Maybe if you've got Air Force One flying above and they don't really want people knowing where it is, probably won't work the same way. As ADSB is not encrypted, it would be relatively simple just to shut down an airport by broadcasting some ADSB signals, which actually wouldn't cost a lot, but that would actually have significant cost implication by doing so. There's a big one at the minute in terms of GPS spoofing that people may have heard in the news. Degrading that signal causes, or even just shifting the appearance of where an aircraft is, the GPS signal is possible. And that integrity of that information is really, really important, especially as we try and do precision approaches and stuff using GPS. Availability, again, because ADSB is not encrypted, all this data is readily available, real time, no delays. Something that supports the ability to compromise integrity. And if we apply the principles of like a military aircraft operation in a civilian airspace, or a law enforcement where a mission knowledge is quite sensitive, there's a key responsibility in the design, maintenance, manufacture, and safety monitoring of this information. So what's driving the industry's direction? Well, I alluded a little bit to before, so hardware equipment standards. So because cyber security it's considered its own discipline. When we're manufacturing boxes, when we're manufacturing equipment, you know, we do vibration tests, we do environmental checks in terms of moisture ingress, you know, temperature temperature range of the equipment can be operated in. But this one here, DO 326A, is a cybersecurity standard for equipment. We also got this DFT strategy, which published in 2018. I'm wondering when the 2023 one's going to come out, but it's a one that's a strategy for 2021 and 2022. And then we've got Part IS as well, which has been created to maintain to to maintain a high level of safety, contributing to the protection of aviation systems against security and cybersecurity risks. I found out that kind of due to these new regulations, regulators are kind of yet to determine how they will effectively apply the governance. I see a lot of regulation. I see some engagement, despite there being a desire and a willpower. Regulation is yet, for example, to obligate that things like something like engine health trend monitoring is not hidden behind a cryptographic wall that has to be paid for as a software as a service, for which the responsible party becomes obligated to use a whole host of different tools and services and infrastructure in order to just get things like engine health trend monitoring data, which is pretty important for on-condition engines. So what do we need? What's important here, I think, is knowledge and awareness. I think if people are knowledgeable and aware of this and challenging it, like I said at the outset, not just because they're trying to be awkward, I think it's because it's really important that actually that responsibility is heard, especially down the supply chain, to make sure that we have got that accountability where it is, because fundamentally, when things happen in this space, it's never the supplier's name that's on the headlines. It's always the operator or the aircraft manufacturing company or something. So it's really challenging actually for industry to maintain pace, especially in digital world. I mean, from a regulation perspective, it's hard to keep pace, but when you put a digital wrapper around it, it's even more so. It moves so fast. There's this big shift towards removing this term, if you've not heard it before, technical debt. If you don't keep paying it down, it gets worse with interest. To use these software tools talked about before, this software as a service, everything as a service principle that I talked about. The information that's gathered by these sort of platforms, these services, is used, anonymized, resold. It's used to work out what more they can sell you. It's also used to perform things like processing activities, like unencrypting information, making it unavailable until you pay for a particular service. This everything as a service market is expected to be worth by 2030 about 1.3 billion. So not only have we got all that information in these massive warehouses, we've got a whole industry behind the selling and commoditization of this information. So how long is it before we see something like cockpit voice recorders as a service? An interesting prospect, isn't it? Imagine if we had a live feed of cockpit voice recordings going to the cloud. Certainly wouldn't need to go searching for a black box, would you? I think whilst that's a bit of an extreme case, I don't think it's beyond reason that something like that would be a worthwhile service. Clearly there'd have to be a lot of security around it. But maybe I'm being flippant. I think, there's arguments both ways for either. I've also got at the bottom here, we've got things like blockchain, digital record ownership, non-fungible tokens. These are all words that you might have heard banded around. Fungible, well, that's just something that's plentiful, or like a print or a replica. When it's non-fungible, that means it's you just can't replace it. So how many copies of a logbook can you have if they're digitized? How many copies of maintenance records can you have if they're digitized? Which one's right? Which one's the true version of the truth, especially when you digitize everything? I think this non-fungible thing will be the thing that actually is leveraged in the future as well. So I picked up this image from a piece of marketing literature, which kind of shows how digital services and how digital service providers are architecting systems. I heard someone say system architect before. I can't remember who said that. There are people who are architects of digital systems, not buildings. So this is an example of a supplier that's got a turnkey solution. So you've got all the data buses from the aircraft going to a box on board, going out over the over different connections, SATCOM, wireless, Wi-Fi. Had a great time getting connected to Wi-Fi today. But this information can certainly make its way off the aircraft. Crucially, against those cybersecurity regulations, as a responsible person for some of this stuff, how do I manage and maintain my confidentiality, accessibility, and integrity of this information? How do I inject myself somewhere along that process to work out, has my data been manipulated? At what point does it get unencrypted? Who's in control of it? Can I check it? Is it encrypted? I don't know. For anybody that's done this sort of exercise, especially when it comes to the cyber regulations for the UKCA, involved a massive spreadsheet, courtesy of, I think, the Department for Transport and CA, which, with not an insignificant number of indicators of good practice, you had to assess this sort of supply chain to determine where your cybersecurity risk was, especially if this is something like EHM or some kind of safety critical system that could impact by not being available or not being correct, could impact the operation. So this is one supplier's view on it. Here's another. It's more innovative, I suppose, approach where you've got this particular organization trying to do all the stuff that I'm trying to say here, which is make it trustworthy, fair, efficient, a little bit more selfless, I suppose. Two different approach. Which one's right? Don't know. Sure, it'll be decided in the longer term. So when we leave here, and probably moving towards the questions, will we look at aviation data differently? Well, I hope we do. Certainly I do on a daily basis, and if there's anything that I can impart, then it'll be that. While someone else is doing it, it's actually still a responsibility of somebody at the pointy end of all of this stuff along the supply chain. And maintaining that challenge is incredibly important. I think anyone that's in a position to challenge that should, and read the small print. That's it. Thank you.
Here is the memento that we like to give our speakers.
Thank you very much.
Which is definitely hardware.
There's no data in there.
No. It's a representation of the Cody Flyer, the first powered flight in this country, which happened in 1908. That's over there.
Yep.
And so we like you can use it as a suitable paperweight for your hardware desk.